Welcome. So this question says a block slides across a level table. The force of friction between the block and the table is 6 newtons. What is a new force of friction if the mass of the block is tripled and the coefficient of the kinetic friction is quadrupled? So this is an example of a ratio problem. It's where you know the answer under one set of circumstances, and then you're asked for the answer if you change, you double things, you halve things, you triple things, you quarter things. And it's easy to get tripped up on these problems, but they are very useful because sometimes all you know is that you did double something. So let's begin by visualizing. So there's my block and here's a certain mass. And I know, for example, that the weight is m times g, g being the gravitational field strength, and this is Fn pointing upwards. That's great. And then I do know that there's a frictional force, Ff, and I know the value of that is 6 newtons. Now, all I know is this object is moving. It may be that there's an applied force, and it may be the applied force balances the frictional force, in which case I'm moving at a constant velocity. It may be there's a huge applied force, in which case it overwhelms Ff and I am speeding up. It could be that there is a small applied force, in which case Ff dominates and I'm slowing down. It could be there's no applied force, in which case I'm slowing down for sure and will eventually stop. So it doesn't matter. All that matters is that I am moving. And I say to myself, under the circumstances where I am moving, how does the frictional force relate to the normal force? And I say, well, the governing relationship is Ff is equal to mu k times Fn. Okay? And I happen to know under the original set of conditions that Ff equals 6. The easiest way to do these, in my experience, is to set up a ratio. So I'm going to say Ff, and I'm going to write nu, because I don't want to put n down because I've got an Fn over here. So Ff nu over Ff old. That ratio will be equal to mu k nu over mu k old. And then we're going to multiply that by Fn nu over Fn old. And with those in mind, I can then, it becomes a mathematical substitution problem. So Ff nu over, what was the value? The value was 6 newtons. The force of friction between the block and the table is 6 newtons. So this was 6 newtons before I made any changes. And then this equaled. And the first piece of information it gives me, maybe they're all needed, maybe there's some extra information in here, but it says, what is the new force of friction? That would be Ff nu. If the mass of the block is tripled, well, if I look here, if I triple this mass, but g stays the same, I triple my Fn. That's just the way it is. There's no other forces there. These two guys are balancing each other because otherwise I would accelerate upwards or downwards, and I don't. So these two forces are balancing each other. If I triple m, then I triple Fn. So how can I represent this? Well, use the simplest way. If the original n was equal to 1, the new one would equal 3. It's going to be 3 times as big. I could have said 2 and 6, or 1,000 and 3,000, or 1 newton, 1 n and 3n, or 1x and 3x. It's just the ratio of 1 to 3, whatever I choose to do it. Then I look and it says, oh, and the coefficient of kinetic friction is quadrupled. Well, if the old one, let's keep to the simplest way, if the old one was 1, then the new one is 4. So when I multiply this out, I get, 12 over 1 if you like. Well, now I have it, don't I? FF new is equal to 6 times 12 FF new is equal to 72 newtons. Now you could say, well, why don't you just, work out the values? Why don't we just somehow figure out what the original value of mu k must have been, and the original value of Fn must have been, and then multiply those true values by 3 and 4. The problem is you got 2 unknowns and only 1 equation, so that's not going to work very well. So at some point you have to assume some values. And by doing this ratio method, I find it works quite efficiently. People feel uncomfortable assuming numbers. We're so used to being given the value to substitute into the equation. And in this case, you're not given that number. You have to assume something. But logic says if I triple something, then 1 goes to 3. And if I quadruple something, 1 goes to 4. So I find you can do quite complicated changes using this method by using the new over the old and keeping the ratios and using this layout. These problems become quite accessible. So there we have it.